Here for it. Okay, so if you were here earlier, I don't know if this, are we good? We're talking?
Check.
Yeah. Okay. Well, wait.
You good?
All right, so if you were here earlier, we went over the entry-level 3D printing technology, fused deposition modeling. So now we're going to progress through the other technologies so that you can get into the higher-end technologies, everything from our powder models all the way up to full-line metal printing. Okay? All right, so again, everybody knows what 3D printing is. Adds the Z-axis to our X and Y, layer by layer. That's the reason for additive manufacturing term. You take your CAD file, save it as an STL. STL, standard file format for 3D printing, not only for 3D systems, but for everybody. That's the standard file format. So 3D printing is a huge industry right now. We hear about it in everything from medical to aerospace. Currently, a $1.5 billion industry speculated to be a $5 billion in 2012 or 2020. All right, it's in, again, everything from dental to medical. So we'll talk a little bit about all those different industries as we go through this. So why do we hear about it now? What's the big deal now? Reason is the price of the printers are finally coming down. Ease of use is coming up. Most people can use it, and if not, we put things in place that you can actually get files fixed and get assistance if you need it. And we're using multiple products in the printers, everything from plastics to metals to nylons to chocolates. So now it's things that we can all relate to, things that we need products made out of. 3D Systems offers a comprehensive line of printers, and the reason I show you this is just so that you know the competition out there is 3D Systems and Stratasys. Those are the two big box companies. It's kind of like a Lowe's Home Depot situation. Why do I say that? Because they both offer comprehensive lines. Everything from entry level all the way up to full line production printers. Now there's a lot of other 3D printing systems out there, but they specialize in their niche. One's a metal printer, one's just a plastic printer. So truly, when you're talking and looking at 3D printers, 3D Systems and Stratasys are the two that you really need to talk to. 3D, of course, I hope you all buy 3D, but 3D and Stratasys both do and operate a little differently, so you need to look at both lines if you're going to make a good decision on 3D printing.
The printer that you had up there, or the one that's in this room on rent,
Okay, on loan. That's the X460 system. That falls into the professional line of printers because it's color.
Okay.
So basically how this is broke down, if this makes any sense, is your lower FDM technologies, also your smaller powder models. Then if you're going to do anything professional, you're going to do something for another customer or make something you're going to use, it kind of falls into professional. If you really want to produce a part to use, that's our production line. And everybody busts it up the same way. Stratasys just calls it something different. And this may help you understand this as well. So all of a sudden I have an idea in my head and I want to look at it. I can use this little FDM guy to print it out. Once I check it out, I say, okay, everything looks good, but now I want to show my customer. I want to show someone else. So now I have to kind of use a professional printer where I'm going to do some modeling, maybe even some prototyping. That's this series of printer in here that we use, or the powder printers. But now I actually want to test it. I want to form fit, test it, snap fit, maybe pattern it, tool it even. Now I'm looking at our multi-jet modeling or liquid plastic technology. So I just make the progression. If I actually want to use the part in a machine, now I'm going to get into the production line of printing.
As I understood from Chris, you could take your model that you built on your real inexpensive machine, and you could send it off to some service, and they'll upgrade that for you on one of these printers.
Right. So you have a couple of different options with that. There are many services out there that will print parts for you. They can print parts for you here. There are production facilities that can produce parts for you. There are huge companies that produce parts for you, 3D Systems being one of them. The name of their company is Quick Parts. They produce you from everything from that FDM technology all the way up to full line metal. And you can get a quote for those very easily. Another one on the West Coast is the Purple Platypus. They're huge.
Is that fairly quick to do that?
They are.
It's about a week,
It depends.
1 to 2 weeks turnaround time.
It depends on what your technology is and how difficult the part, and if they've got it set up, and if everything's in a perfect world. If you find a little local guy, and I can actually give you one, you're going to get a much quicker turnaround. I've got resellers that will turn a part around in 24 to 48 hours for you. So it all depends on what you want and what you're looking for. All right, so this is what the line of Sterling offers. Keep in mind, Sterling has the ability to get you anything from this FDM all the way up to a direct-to-metal printer, but this just kind of keeps reiterating these terms I keep using. Fused deposition modeling, the X60 series, the ProJet series, which is multi-jet modeling, up to the SLA and SLS. SLS is stereolithography, been around since 1986, probably one of the best technologies out there. SLS is laser sintering, so we'll look at that as we go through. That should become clear as we progress. So again, we looked at this. This is the Cube Pro. Fused deposition modeling, melted plastic. Little guys, 6x6x6 print space, up to the bigger guys, which we have in here. You can print about the size of a basketball. All right, in this series, they're coming out with some new products. This is just kind of a fun slide. The Chef Jet was actually going to print chocolates. The Sarajet, which is a green ceramic printer, so now I'm going to be able to do customized flatware, customized dinnerware. You'll still need fire in the kiln, so it may eliminate the pottery wheel.
You do custom mold that process too. So if you're dealing with something with molds and you use a ceramic mold process, that can also, for $10,000, be a very valuable tool.
They're also coming out with a desktop version of this printer in here, the X60 series. We're not expecting to see that till late in the year, but it'll actually be a desktop version of this full color model in here. As well as a 3D Me photo booth, which is basically the old school photo booth. You sit in, it scans your face. You get out and order yourself on a figurine or a bobblehead, and it comes to you shipped in a couple of weeks.
A Disney character or an NBA star or whatever.
All right, so we're going to go to the next technology above this, and stop me at any given moment, because sometimes I'm going to cover a lot of technology quickly here, so if you have any questions, let me know. So this is the next step in the technology series. We looked at the FDM. Now we're going to look at what is known as color jet printing. This is the powder model in here. This is the only full color printer on the market space, and it's used for anything visual prototyping, architect, engineer, contractor modeling, GIS mapping, bobbleheads, figurines. You can see anybody that's going to need a good color model. So how's it work? It actually takes core, which we use in here. We're using the gypsum powder model. It's held together with a color binding solution, colored glue, pumped through standard print heads, 57 and 11 each piece off the shelf. We ran out of color here. She ran over to Walmart and got us a new print head. So this is standard off-the-shelf products. Once your parts are done, we treat them with an infiltrant or a hardener. It can be anything from Epsom salt water to epoxy to super glue to wax. So multiple infiltrants are available. So what it does is it takes this vat of powder and it spreads a thin layer across the platform about the thickness of a piece of paper. Behind that become the print heads and the glue. It deposits that. Anywhere you put down that glue is going to be the part. Comes across again, puts down another layer, and keeps going back and forth until that's done. All of your parts then are built under that powder. The support system, like we talked about earlier, is the powder itself. So once it's done, we'll have a whole vat full of parts. And this is running in here, if you want to look at this when we're done here, and it's doing this process. Once the parts are built, we take them out of the printer part, we move it over to the finishing station or the finishing side, where we blow it off, clean out that excess powder, then we dip it in that infiltrant. Some of these printers vary in models, everything from the model you see in here, which is CMY, the K is actually blended, the black, so you get kind of muted blacks, all the way up to full line color binding solution through color print heads for really true deep colors. And you'll see that now that I said that, right? Robert can show you some parts that show the difference in those. Parts cost on these units range anywhere from $3 to $10 a cubic inch. It's going to depend on how many parts I'm printing at the same time, what mode I'm printing in, how many colors it is. Parts calculators are available right in the machines. It's going to tell you how much you're going to use. It won't let you complete a job or start a job if you don't have enough supplies. So it's a pretty smart kind of system. It won't let you, be dead in the water after you start to print. Again, it is the only full color printer on the marketplace, so if color is important to you, this is the only full color printer out there. And you can see the difference in the parts just by looking at the color, and you can see that back there. Again, multiple models available. 160 is the little guy, 860 is the big guy. He looks small there because the finishing station is actually a separate piece. The only difference is color and vat size. So those are the two most important things in this model. So any questions on that technology? This is what it feels like. I'll pass this around. You can feel it. It's got that gritty, sandy feel, almost like lava soap. And that's how you'll be able to tell if anything was ever created with this type of technology. It's the feel. The same color jet printing technology is available not in the gypsum powder, but in a powdered acrylate or a powdered plastic. So now all I've done is the same process. It fills the vat. Or first I have full, now I got a little bit more strength to these parts. So now I don't have to worry so much about them breaking. It's a little more flexible. The colors are kind of muted because they're actually melted together, and I'll show you that. But that is powdered acrylate or powdered plastic. Works the same exact way. Spreads a thin layer. Print heads come behind it and put down the glue and the color. Then comes behind it a heater, so it melts it together. All right, so that is the color jet printing technology.
That's the cell phone case coming around.
All right, so now we'll get into the next technology. It's called multi-jet modeling. Same printing technology, except it's taking a vat of liquid plastic, jetting it through a standard Xerox print head, dropping it to a platform where it's UV dried and cured. And I'll show you that coming up, and we'll pass around some parts. Multiple models available in this printer. This is truly the printer that you're hearing all about. This printer will print, you buy it accordingly, but you can get a plastic printer, you can get a wax printer. Wax printers for anybody that does the old lost wax casting processes, or you need a mold of any sort. You got your dental printers. This is where they're doing your dental molds, your crowns, your Invisaligns. All the way up to your medical printers, where you're actually printing medical devices with a Class 6 material. Again, this is how it works. They call it phase changing, but it's basically inkjet technology. Drops it to the platform, UV dries and cures it. It uses the plastic, and wax is the support system. So what happens is when this is done, your part actually is covered in wax, and I'll show you a picture of a full platform of parts. I stick it in a low temp convection oven, melt off that wax, and then my parts move freely. So I'm able to print fully functionable parts with this printer. All right, so this printer is known for design and printability. As you can see, I'm getting true parts that I'm going to put in my printer, or put in my machine to test snap fit, form fit. Almost looks like injection molding. I'm able to print details, textures, patterns. Microfine details and resolution. We've got quite a few parts in here that you can take a look at. But this is truly one of the most accurate printers out there, besides the SLA technology.
This is your 3500.
This is the 3500 series.
What's the price on that?
You can get into a 3500 for anywhere from $50,000 to about $125,000. And the difference in the printers is just resolution and speed. It starts at just a high definition mode, goes to high def, ultra high def, extreme high def, loaded up, and high speed. So you just add more buzzers and bells to get there. Most of the time, if you're not printing a part that is this detailed of a resolution, then you really just need an HD model. So this is what a full platform of parts look like. This is actually the plastic printer. As you can see, this is the plastic, the off yellow color. The bottom is all wax. That's the white is all wax. So all this is wax. Stick that cookie sheet looking thing into a low temp convection oven, melt it off, and then my parts move freely, so those pliers would actually move. So all your voids are filled with wax. That's how you get your moving parts. It's always hard for people to comprehend, but that's how it works.
This is a great system for office environments, whereas old SLA technology is not really suitable for office environments, and some of the other competitive technologies are not suitable for office environments because of the invasive post-process where you have to have either chemicals or water to get rid of the support structure. In this situation, you can put it in that oven, it comes out and it's ready to use, and there's no fumes and there's no hazardous materials.
So on the top, you see the wax on wax system. That's what that blue is. So now I've got my wax molds for my rings and my jewelry. Along with this technology, this multi-jet that's jetting through the print head, there's a new printer out called a 5500. It's the first dual composition, dual material, multiple materials. So now I'm jetting everything from a white ABS-like material to a full-line rubber material, and I can mix those in between. So, as well as clear prototyping. So this is an example of that. This was produced at the same time. So the top is obviously rubber, bottom is plastic, and any combination there between. So here's a great example of this little car. I'm able to print both the plastic body and the rubber wheels at the same time. Flexible prototyping as well with that rubber, which is new. So if that's critical, as well as clear. This is the first time we've had clear prototyping available.
In this type of technology.
Can you have all three at once, or is it?
Absolutely. Absolutely. You can blend them. You can.
Two.
What?
Two materials blended together. You run two. You can't run the three. You either run the two and blend them, but two together. So it's rubber and plastic, clear or rubber. Two.
Couldn't crank the clear ABS and rubber side.
Yeah, we're talking across each other, but what she's saying is you can take two types of materials, whether it be clear, and then blend that as a gradient all the way from completely clear to rubber. And you can have a gradient of materials all the way through.
Okay? All right, so that is the multi-jet modeling technology. Any questions with that? All right, now we'll keep progressing. If you go back to my original slide where we had this idea, we tested it, now we've snap fit, form fit, now we really like it, now we want to produce it. Now we're at that stage. Anytime you talk about SLA and SLS technology, it's truly a workable part. I'm in production. I'm producing a part. SLA, again, is the oldest form of printing. It's stereolithography. It takes a vat of liquid plastic and uses a laser beam to trace the part. It does that continually, and it keeps spreading micro-thin layers about the thickness of a piece of paper over and over again until we get the part. It is laser beam technology, therefore it's very accurate and very precise, and now I'm able to replicate production parts. Multiple products available in this line as well. As you can see, very durable parts, high temperature parts, clear parts, tough parts, casted parts. This is our true production printer. SLA is the most versatile production printer out there. Then we get into SLS. That's laser sintering process. What that is, and this is the metal line as well, all the way up. It takes a vat of the powdered material, be it metals, is a good example. The laser beam then comes down and traces the part over and over again, layers it just like this machine in here, except I'm using lasers. Therefore, much bigger unit and enclosed.
Are there any shear lines like with the plastic, or is this?
I'm sorry, I missed
Do you
that.
have the problems with the shear lines that you did with
No.
the others? None of that?
No,
So
not
this is
anymore.
actually fusing one layer
Right.
to the other using a high temperature laser. So the parts that come out of this are stronger than traditional manufacturing.
And then I can temper it as need be after that to get the final desired effects?
Yeah, and usually tempering is not required because of the nature of the process.
Or case hardening?
Yeah, usually this is going to yield a superior structure. The structure is actually going to be better than some of the post processes we've used with other metal processes, foundry processes, because of the way that the laser is forming the molecular structure. It's much,
crystal alignment.
right, it's much stronger and lighter than most traditional foundry parts.
All right, as you can see, no tooling, completely design free, which is exactly what you were talking about. No longer do I have to do any post-processing. It's completely design free. Functional metal parts in hours.
And this type of manufacturing, you can produce things that can't be produced any other way. Jet engine nozzles, things that just can't be produced, manifolds that can't be produced in a foundry situation.
So again, it's always the question is always that I'll ask you a million times, what do you want to do with the part? What do you want to do with the part? That'll get you into the right printing technology. So whether it's a 3D systems technology or a Stratasys technology, what you want to do with the part drives you to the technology that you need to accomplish your job. So always make sure you're getting in the right technology, because that's a little different in this 3D world. Your technology, you have to decide what you're going to do with the part to get you to the right technology. And I kind of just use this for a cheat sheet so I know if I want to do verification models, I get into that type of series. If I want to do pre-production or true manufacturing, which parts or which printer I would use. So again, I stress all the time, find your application. What do you want to do with the printer? Find your right printing solution, and then find the right partner, because your partner will help you get into the right technology. If you don't, you won't like us much. You have to get into the right printer. And that is a lot of information quickly. Any questions? All right. We're over here if you want to talk about anything. We've got parts from all of these printers over here. Or if you want to ask any more questions, feel free.
You said something went wrong with the pen process? Was
Yeah, I did that.
that.
Thanks for calling me out. No, actually what we did is when we printed the parts, the post-processing requires you to infiltrate them. So we printed them in 3 parts. I assumed he had put everything together before I dipped them. So I just made them not as flexible and able to thread as easily. So they just require some work. So you're welcome to take one, but you'll have to do a little post-process. Maybe it's a test for you. All right, anything else? All right, guys. Now you're specialists in 3D printing. Thanks, Denise. No problem. Yeah.
Yeah, let me show you how that works.